Welcome to this lecture on Laplace transform. So one of the major applications of Laplace transform is in the solution of linear ordinary differential equation. When you take Laplace transform of a differential equation, ordinary differential equation, the differential equation changes into simple algebraic form. So it becomes easier to solve the differential equation. So we'll illustrate the use of Laplace transform to solve a differential equation. This is a linear ordinary differential equation, second order differential equation. d square y by dt square plus dy by dt equal to t square plus 2t. The initial conditions are given as y0 equal to 4 and y dash 0. This is first derivative, y dash equal to minus 2. Now let us take Laplace transform on both sides. L of the left hand side equal to L of right hand side. So let us we'll split this into two terms, L of d square by dt square plus L of dy by dt equal to L of t square plus L of 2t. So I return the Laplace transform. You have to recall the Laplace transform of nth derivative. So this is second derivative. The Laplace transform of d square y by dt square is s square into I of s minus s y0 minus y dash 0. So recall the first part of the lecture on Laplace transform, where I had given the table of transform. I had given the Laplace transform of nth derivative. So this term is Laplace transform of the second derivative, s square ys minus sy0 minus y dash 0. And the Laplace transform of this is this first derivative. L of first derivative is s into I of s minus y0 equal to L of t square. L of t square is 2 by s cube. Okay. You'll recall t power n. L of t power n is n factorial by s power n plus 1. So L of t square is 2 factorial, that is 2 divided by s power 3. Then L of 2t, 2 is constant, so 2, L of t is 1 by s square, so L of 2t is 2 by s square. So I just taken Laplace transform of the left hand side and Laplace transform of the right hand side of this equation. Now let us substitute the given initial values. y0 is given as 4 and y dash 0 is given as minus 2. So this y0 is 4 and this is minus 2. This is minus 2. So if you substitute, y0 is 4, y dash 0 is minus 2, so minus of minus plus 2. Similarly, this y0 is minus 4. I just substituted the given initial values. These three initial values are given. I substituted them here, and here. Then let me simplify this. Taken y of s common into s square plus s, this minus 4s and minus 4s, and then plus 2 and minus 4 make it minus 2. The right hand side is as such, 2 by s cube plus 2 by s square. So right hand side, if you simplify, it is 2 plus 2 by 2s by s cube. Now I have brought this minus 4s minus 2 to this side, plus 4s plus 2, and next step I have taken this common LCM, s cube as common LCM. So if you take s cube, 2 plus 2s to 4s power 4 into 2s cube, this. So I had simplified this term into single term, 2 plus 2s plus 4s power 4 plus 2s cube divided by s cube, and I brought this s square plus s this side, denominator to the denominator of this side. And this is for the simplification. This s is common, so I taken one s. This will combine with this s cube. It becomes s plus 4, s power 4, s plus 1. This I written same. First term I written in the decreasing power of s, 4s power 4 plus 2s cube plus 2s plus 2. So this differential equation, by after taking Laplace transform, has been transformed into a simple algebraic form. Y of s equal to 4s power 4 plus 2s cube plus 2s plus 2 divided by s power 4 plus into s plus 1. Now you have to find the inverse of this. You have to find the invert. If you invert, you will get y of t. Solve means what? Solve this differential equation means you have to find what is y of t. Okay, what is y? What is y of t? You have to find out. That is the meaning of solve. So solve means you have to find what is y of t. That's the meaning. So we have found y of s. If you take inverse, you will get y of t. Now how to take inverse? There are different methods. One is by means of partial fractions. So let us split this term into partial fractions. So there are factors. You have to factorize the denominator first. It is already factorized. There are actually how many factors? S plus 1 is one factor, and there are repeated roots, 4 roots. So there's 4 plus 1, 5 factors in this. So we'll have 5 constants. So if you split this y of s into, you have to split this into factors. There are already 5 factors in this, so we'll have 5 constants. So if you split this into 5 constants, you'll have a by s plus 1, b by s, c by s square, d by s cube, e by s power 4. So the s is repeated roots, repeats 4 times, so you'll have 4 constants, b, c, d and e, b by s plus c by s square plus d by s cube and e by s power 4. So if you multiply throughout by the LCM, that is s power 4 into s plus 1, and this right hand side is the same here. This is RHS same. So if you multiply by this, LCM, what are you going to get? A into s power 4 plus b into s cube into s plus 1 plus c into s square into s plus 1 plus d into s plus 1 plus e into s plus 1 equal to this. What is that? 4s power 4 2s cube 2s and 2. Now you have to evaluate these 5 constants. You can assign some. There are again 2 ways. You can number 1 is you can assign some values of s on both sides and evaluate the constants, or you can compare the coefficients of like terms. So here, if I first let me assign s equal to 0. If I assign s equal to 0, what happens? This term becomes 0, this term becomes 0, c term becomes 0, d also becomes 0. On the left hand side, you get only e into s plus 1, s is 0, so e. And on the right hand side, when s becomes 0, right hand side becomes 2. So you get e equal to 2. Now let us assign s equal to minus 1. That also makes things easier. If you assign s equal to minus 1, What do you get? If you assign s equal to minus 1, this term becomes 0, this becomes 0, this becomes 0, this becomes 0. Only a term is left, and minus 1 power 4 is plus 1, so you get a equal to, and on the right hand side when you put s equal to minus 1, 4 minus 2 plus 2, so you get a equal to 2. Now you can assign some other values as equal to 2 or 3 or anything. Easier way is compare the coefficients. So that will be easier. So let us take S4 terms. So if you compare the coefficients of S4, left hand side you have S4 term, there are only 2. Okay, you have a here and b s power 4. There is no other s power 4. So if you compare s power terms, you have a plus b, and the right hand side a plus 4. You have s power 4 is term is 4. So a plus b is 4, and a is already 2. A is already 2. So this means b is also equal to 2. So we have found out a, b, and e. So we have to find next c and d. So let us compare s cube terms. S cube terms you have here, where is s cube? You have here bs cube, this, and cs cube, that's all. So bs cube and cs cube you have, so coefficients are b and c, and the right hand side s cube term is 2, coefficient of s cube is 2, so b plus c is 2, already b is 2, so this means c is 0, b is 2 here, b plus c also 2, that means c equal to 0. Now let us compare s square term. What are the s square terms? There is you have cs square c here and ds square d, cs square here and ds square. So you have c and d in the left hand side, and in the right hand side there is no s square. There is no s square on the right hand side, so s square term is 0 on the right hand side, left hand side c and d. So c plus d equal to 0, and c, since c is already 0, this means d also equal to 0. So c is 0, d is 0, b equal to 2, a equal to 2, and e equal to 2. So let me substitute the values of a, b, c, d, e in this equation, in this. So if I substitute, I'm going to get, so when I substitute a, b, c, d, e values in this equation, a is 2 by s plus 1, 2 by s plus 1, b is 2, b is also 2, so 2 by s, c and d are 0, so this term, these two terms become 0. Then e by s power 4, e is 2, so again 2 by s power 4. So I of s is going to be this. Y of s is this equation. Now if I invert this, we are going to get y of t. So what is the inverse? What is the inverse? Take inverse, all inverse, y of t. What is the inverse of 2 by s plus 1? S plus a. 1 by s plus a is what? 1 by s plus a is e power minus t. 2 e power minus t. 1 by s is inverse of 1 by s is 1, so 2 by s is 2, and s power 2 by s power 4. What is the recall? What is the Laplace of t power n? If you take L of Tn, is n factorial divided by s power n plus 1. So if you take t power 3, what is L? Well, Laplace transform of t power 3 is 3 factorial by s power 4. So if we invert 1 by s power 4 inverse is t power 3 by 3 factorial. So if you substitute here, so what will be inverse of 2 by s power 4? It will be 2 to t power 3 by 3 factorial. So that will be equal to 2e power minus t plus 2. 2 by 3 factorial is 3 only. 2 by 3 factorial is 3. So I of t, the solution is y of t equal to this. So this is the answer. So the solution of the differential equation is this. The solution of the given differential equation, what we started with, this equation is this. Y of t equal to 2 into e power minus t plus 2 into t cube by 3. So we have taken Laplace transform, got an expression for I of s, and we split that into partial fractions and took inverse, we got this. So this is one way of finding the inverse. We'll see more examples in the next part. So if you like this, please leave your comments and please subscribe to the channel. We'll see you later in more lectures. Bye.